Recording this is Oscar level stuff here, man. All right. Do you guys any questions? You could have general questions. You could have specific questions. Oh yeah, don't forget. I also put up here, not surprisingly, I put up here a practice quiz.
The quiz is still tomorrow?
No. Take a look at the homework sheet. It was updated. I moved it to Thursday. So here's the practice quiz. Oh, it's a thing of beauty. All right. And eventually, maybe tomorrow, I will unleash the answer key. I have it in here already. See here, right there, see it? You can't see it in your canvas, but I can see it in my canvas. All right, so it doesn't matter. Let me unlock it now, screw it. Bam, it's unlocked, now you can see it. Oh yeah, understood. Somebody's just telling me over chat that they got the vaccine and they're gonna be a little out of it. And I'm like, dude, second or first person who's chatting to me? Oh, first shot. Okay. My first shot, I don't know. Everybody's different. Mine was not bad at all. I could feel it, but it was, the second one, of course, as I've talked about, completely knocked me on my ass. Yeah. Anyway, anybody, any questions before we're just going to get right back into law of cosines and stuff. If
I'm still struggling a little bit with 36. I plugged in the flipped tangent to x, but there's still a 2 in front of it, so it's 2 times that. And from there, I'm still kind of lost.
So this is one, let me see. All right, let me see if I can pull this up. Here we go. So again, if you don't have this sheet sitting next to you, and I know that Jordan does, but if you're doing this homework and you don't have the sheet sitting next to you, you don't make much sense. Now let me ask you guys. So this is a question that she was asking me earlier in office hours. Do you see how there's a cotangent of a double angle? Yes? What is wrong with you, monitor? All right. Do I have a cotangent of a double angle formula anywhere on this sheet? I have tangent, don't I? Which means I have cotangent, because how does tangent relate to cotangent? How do they relate to each other? How does cotangent and tangent, how do they relate to each other?
1 over n.
Yeah, one is the reciprocal of the other one. So if tangent 2 theta is 2 tangent theta over 1 minus tangent squared theta, cotangent is 1 minus tangent squared theta over 2 tangent theta. Are you guys with me out there? Do you understand? The basic trig definitions, like the reciprocal identity, what am I drinking? They don't go away. They're always there. They don't give a shit what the angle is. What's cosecant of omega? 1 over sine omega. It doesn't matter what's in there. This is about what cosecant and sine, how they relate to each other. So just because it's tangent to theta doesn't mean it's different. It means it's the reciprocal. Cotangent is the reciprocal of tangent to theta. No worries. All right, so let's come back to this. So let me write this down then. Let's see. I can write it down right here, and then I can do some neat shit. Okay, hold on. All right, I can do it, Jeff. Cotangent to theta equals 1 minus tangent squared over 2 tangent theta. All right. Then I can do this. Pop! Oh, you're so creative. All right, here we go. Where am I at? There it is. So this guy. So therefore, what's cotangent to x? Well, cotangent to x equals 1 minus tangent squared x over 2 tangent x.
But there's still that 2 in front.
Yeah, I forgot the 2 in front. Thank you. This is very, very, very important. So that just kills this, right? Oh, why am I doing so much for you? And then can't you just split this up? Do you see 1 over this minus this over this?
Yeah, I see it now. I was
You're
just confused about the 2. I didn't realize you could cancel it, even though it looks extra awkward is all, I guess.
Oh, this is 2 times. This is divided by 2. So of course they want to kill each other.
That's super fair.
Yeah. Okay. Let me show you this. All right. Let me see. I was thinking about doing this. Is this? Let me see. Where did it go, Jeff? Here it is. Let me double check something. Hold on, guys. Because again, I'm going to try to help you out because I feel like there's more questions out there than are being asked. So let me double check something before I work on this with you guys. Let's see. Come on, Jeff. Hurry up. Hold on. It's taking you so long. Be quiet. That looks good. That looks good. That looks good. That looks good. That looks. Oh, is that the same one? No. Okay, good. All right. And then this is some other weird shit. Yes. Okay. So let me show you what I'm talking about. Oh, wait. Let me save this in a better way. Oh my God. Come on. Let me save it, you crazy computer. Okay. Now I saved it there. Who cares? It doesn't matter, Jeff. It doesn't matter where it is. Okay. So of course I have, like, for example, I have Verizon. And does anyone else have Verizon? Did anyone else experience crazy outages today? I did. The whole network went completely down. It was fantastic. So that was awesome. And now my computer is just screwing with me. So, oh well. All right, we're gonna get through this. All right, so look here. Let's do these together because you guys are not asking me questions, but I know you must have questions about trig identities because they are strange. They just are. Oh, didn't we? Oh, wait, did we do this already? It's very possible we did this already. I don't know.
As a homework?
No, just together. No, I know we did this.
But we never finished.
All right. So I know we did this first problem because I remember pointing out this one has 2 cosines. So just to remind you guys, my favorite thing to do with trig identities is if I see a part of something that's almost what it's supposed to be, I know the equality is supposed to be true. It says verify. So that means the equality is true. I'm just supposed to show it's true. What I'm going to do then is I'm going to divide top and bottom by cosine. Because now the top is right. The top is correct, right? You with me? I don't know if this makes sense to anybody. But this is such a beautiful thing to realize. And I think I use that same trick on part B. And then what do you get? What do you get on the bottom? What is 1 divided by? Is everybody cool with what just happened? I divided the top by cosine. And I divided the bottom by cosine. So you get 1 over cosine. Are you guys out there? Are you guys with me? What is 1 over cosine?
Sine.
No, careful.
No. Sorry, secant.
Secant. And what's sine over cosine?
Tangent.
Tangent. And then we're done. Do you see that? We're done. Now, can somebody show me in part B, is there a way I could use that same thing? There's actually a few different ways you could do part B. But I don't know. Does somebody have a suggestion on what to try for part B? So, all right. Do you see a part of part B, for example, that is related to an identity? What's the most basic trig identities? Can somebody identify for me The most basic trig identities. What's sine squared plus
Cosine squared.
equals
1.
1, for example, right? So when I see squares, like over here, I could, if I didn't see something else to try, I could try to rewrite this as 1 minus sine squared and see if it gets me anywhere. Now in that case, it would have sucked. It would have got me nowhere. But do you guys see this here? What is sine squared?
1 minus cosine squared is.
Yeah. So this is not actually the way I was going to do this problem, but let's just try this out. All right, now stay with me. You've got to internalize my motivation for what I'm doing. Am I going the right way right now? I have no idea. This is exciting. I'm just showing you something to try based on what I saw in the problem to show you what to look for, what the flexibility is. Now, why do I feel like I might be going in the right direction? Because could somebody help me factor the top? Can you factor the top of this?
1 minus cosine x times 1 plus cosine x.
And on the bottom, of course, is 1 minus cosine x. And what happens?
Cancel.
Will you stop at screen? All right. So I've got this side. I can't do anything else with this side, can I? There's really not much else I can do with that side. It's 1 plus cosine. I don't know why I'm writing so small. I'm sorry. So let me do something on this side. Does somebody see something I can do on this side? What's kind of an obvious thing I can do on this side here?
All the secants are 1 over cosine.
True. I need you guys to look for this with these fractions. Can't I tear this fraction apart? Right? Isn't it 1 divided by secant? Plus secant divided by secant? Yes? Are you guys with me out there? Why couldn't I do that with this fraction?
Because the top one is sine
Yeah, the
squared.
top has to be the one that's connected with addition subtraction. Right? So like 4 minus 3 divided by 5 is 4/5 minus 3/5 all day long, right? This weird question. And that, but 5 divided by 4 minus 3 does not equal 5 divided by 4 minus 5 divided by 3. Holy shit. Okay. Now again, Jordan, to be really honest, there was not a damn thing wrong with your suggestion. Do you understand? But there was a more basic thing you could notice here. And of course, secant divided by secant is 1. And what's 1 over secant?
Cosine x.
Cosine. Please draw that arrow for me when you're done. That kind of signifies to me where the last step was and that you see that they're equal. Does that make sense? Show me something. You gotta show me something about what the hell. Why did you stop? Are you done? Show me you're done. All right. You guys try something on part C. And again, I said this yesterday. If you have not printed out that green sheet of identities, if you haven't printed it out, or at least put it up on your screen, so you can have it sitting next to you. Eventually, you have to memorize this stuff. Yes, for sure. The correct ones, right? The stuff at the top. But for now, gives a shit, right? Just have it sitting next to you as you do your homework, as you do stuff. So hopefully everybody's doing the most obvious thing to do. There could be something I don't see. So if somebody did something other than this, let me know, because there could be something really cool I'm not thinking about. But can somebody tell me what they're doing?
I used double angle formulas.
Yeah, double angle form makes sense because you can't show that both sides are equal until you get the angles to at least be the same. That's the first thing you want to do. So somebody else. What is sine of 2x? How can I rewrite that? Just look at your sheet. That's all you got to do, guys. This is your time to shine. Yes?
Oh, it's 2 sine cosine.
2 sine x, cosine x. I like it. Be really, really, really careful.
Yeah, because
This isn't about just you. Don't worry. I'm not just talking about you. But if you write this, that is wrong. This technically says, and again, I'm not coming down on you. Do you understand? I've seen this in the homework a lot. This means 2 sine of cosine x. That's what that means. Because sine sitting all by itself doesn't mean shit. It means it's sine of what's sitting next to it. So oh, no, I don't want that, right? Okay, maybe. All right. Now, what sucks about the bottom? Somebody else. What sucks about this guy? Another example of cosine being an asshole.
He's got a bunch of different variables, pretty much.
Yeah, jackass, right? So I've got to figure out which thing to use. So what are the possibilities? What are the options? Somebody else tell me, what are the options? Cosine 2x could either be what? Somebody else, just look at the sheet and tell me. It's not a hard thing. It's your time to shine. Is it too easy of a question? Are you guys like waiting? You're like, I ain't got to say nothing until he gives me a hard one.
May I say one now?
Sure.
Okay. 2 cosine squared x minus 1.
All right, so it could be 2 cosine squared x minus 1. It could be cosine squared x minus sine squared x. Or it could be 1 minus 2 sine squared x. Those 3 options. So if you can't tell which one is going to work, you just try all 3 until you get the one that works. Can anyone see which one might be a good one to use?
The 2 cosine squared x minus 1.
What
It
told
looks-
you that was a good one? Sorry, go ahead.
Because the ones cancel out.
Yes. There are several reasons, but the most immediate reason why this is a really good candidate is it's going to kill this extra 1 flying around. Do I have any 1 plus shit at all in what it's supposed to become? No, I want that to go away. So if I replace this with the second option, it's going to go away. Die, and then the 2 dies, die 2, and then one of the cosines dies, and then I get sine over cosine. What's sine over cosine? Frickin' tangent, done. It all gets dominoed at the end there. And
Do
again,
you ever get homeworks that look like that?
they look like what I just did.
Yeah.
All right, so what I just did would be bad. Why am I doing this then? Why am I doing this as if it's okay? Because it's okay right now because I am talking to you. It's if each of you turned your homework in by talking to me about as you do each problem. First off, holy shit. And then secondly, something like this would be fine. But if you're doing your homework, let me show you what your homework should look like. Just start over, Jeff. So that's a good point, Jordan. But this works because I'm sitting here in front of you talking to you. That's why this works. But on your homework, you would do something like this. Then the next step. You can write, Jeff. Screw it, I can't write. I forgot my cosine x. Right? And then the 2's cancel, and then one of the cosines cancels. This is sine x over cosine x, which is tangent x. Draw a line. You forgot your x, Jeff. It's okay. Draw a line. Yay. Okay. Because I can't follow along as you're doing stuff. Am I actually doing that? All right. All right, wait a minute. Sorry, guys. It's just a bad technology day. Did I do this with this? I did all of this with the wrong. Oh, I love it. Sorry. So, of course, Zoom's got a built-in annotation thing, right? And, of course, the one I should be using is this. And I'm not using this. So hopefully you've been writing this down because all this is about to go away. You ready? It's going away. It's gone. It's gone. Okay. Let's see. Now let's try this, Jeff. There you go, buddy. What do you think I should do on this one? What's some work? Where's the work to do, right? That's what you look for most of the time, not all the time. You look at where is there work to do. I think somebody was about to say, I'm sorry, I cut somebody off.
Is it like we're putting a common denominator or?
Yes. You've got two fractions on one side and the other side doesn't have any fractions. So the problem is screaming at you, please combine these frickin' fractions. I love it. All right. So of course, what do I do to get the LCD? What do I multiply this first two by?
1 plus sine x.
Good. So that'll be 1 plus sine x over 1 minus sine x, 1 plus sine x. Good Lord, Jeff. What? You can't write worse shit. Oh, yeah. All right. I'm not going crazy. And then what do you multiply this other guy by? Of course, you're going to multiply him by 1 minus sine x, because that's what he's missing, poor little dude. Is everybody with me? Do you understand the motivation? That's the most important thing. This problem right here specifically, doesn't mean shit. It's less than shit. What's important is, what is it about the problem that made me think to try what we're doing right now, right? That's what's important, because I'm not going to give you this problem. I'm never going to give you this problem. You're never going to see the problem again. I'm going to give you problems like it, right? That's what's important. Okay. Now, what's the bottom become? This is a nice little like difference of squares buddy system here, right? Austin, I don't know if you're talking to me or I think Austin's talking to somebody else. He's doing a lot of talking. I don't know what's going on. He might be live streaming.
Yeah. I was making a joke that like I'm gonna make that as a new identity. That exact problem equals shit. Less than shit.
Get this tattooed somewhere, and underneath it have LTS, less than shit. All right. What does the bottom become?
1 minus x squared minus sine squared x.
Yes, 1 minus sine squared x, which is an identity. And what's the top become? 1 plus sine x plus 1 minus sine x. What happens when you get the top together?
2.
2, because the signs cancel, and 1 plus 1 is 2. That's crazy. What's 1 minus sine squared?
Cosine squared.
Cosine squared. And what's over cosine squared? How can I rewrite over cosine squared? How can I bring this up top? What I rewrite it as?
2x.
No.
Secant.
Secant. And that's exactly where I'm supposed to be, right? Maybe. This is a little too pretty, actually. I mean, I don't know. What do I mean by that? I kind of like to do something where I try something and it doesn't work. And I've just gotten lucky here so far, I guess. Because I trust me. I don't care how much math you know. A part of the process is trying the wrong thing. I've said this before, but you guys don't seem to believe me. you try a problem out once, it doesn't quite do what you want it to, and you're like, screw this shit, I don't know. And I'm like, that's perfect. You're doing fantastic. You're supposed to do that. That's supposed to happen. All right. But this one, these are pretty straightforward, to be honest. I mean, what would you do would you work with this side? Does that look like a good side to start with? No, there's not much going on. This side is like, holy, there's a ton of stuff going on. And what is it about this side that I could start with? What about that side has an identity directly related to it?
Some difference.
Yes.
or number.
Cosine x plus y. All right, so go ahead and do it. Everybody, just please, if you're out there, just try it. I don't care if you'd rather be playing, what's that game now? Outriders? Is that what it is? Fallout? Anybody play Fallout? No?
Those are very different.
I know. Well, not really. Outer Worlds? How about-
Also, Fallout hasn't come out with a new one for a little bit. 76
Well,
was the last one. Improved.
technically, they just had a massive update, so it's anyway. I'm showing how much of a geek I am with it. Anyway, sorry. If you have no idea what I'm talking about, that's probably good. That's probably a good thing. So again, you look at your sheet and you look at what, I can't remember how it's written on the sheet. Is it A and B? I can't remember. Yeah. And you're just going to replace A with X and B with Y?
Well, alpha and beta, but yeah.
Oh, alpha and beta? Okay, even better. But the way I remember this is cosine's a complete asshole. So cosine, cosine. It's all about cosine. Oh, you have a plus? Well, I'm going to make it a minus. Screw you. And then you can go sine. Go ahead. You bring up the rear. All right. So look what happens here. What happens in the first piece? If I break this up, again, the same idea, I'm going to break it up. What happens here? Maybe you should write this out. All right, so I get cosine x, cosine y, over cosine x, sine y, minus sine x, sine y, over cosine x, sine y. So, of course, what happens here?
The cosine x cancels.
Now, what's cosine y divided by sine y?
Tangent y?
No.
No.
Tangent.
Cotangent.
Cotangent.
Tangent is sine over cosine. Cotangent is cosine over sine. So over here, what happens? The sine y's cancel. So now you guys got this bad boy, right? What's sine x over cosine x?
Tangent x.
And what do we do next? We just draw arrow because we're done. We got it. We're done. Yay. I understand. I understand. I am used to loving something and all the students absolutely despising that thing. I'm used to it. I love these things. You guys hate it, or maybe not. I don't want to talk for everybody. But it's primarily because this is the first place. You could play around with shit before 176. You could play around with shit in earlier math courses. But this is the first place people are playing around as a requirement. And you're just not used to playing around. You're not used to feeling okay playing around.
Do you ever just notice that it looks like you're writing like sinks and sine?
Yes. Yeah. Dude, don't even get me started. There's other, anyway, so later we'll learn some other stuff, which is really hilarious because then, well, we'll learn some stuff later. Just to drop a little teaser, we'll learn hyperbolic trigonometric functions, where we'll have stuff like sinh and cosh. And
Just like
tangent.
this is Cody minus tanks.
Yes. Cody taking on the tankies. All right. Look at these bad boys. All right, let's blow through these. All right, I really like that last one. The last one's yummy. This first one, we've done stuff like this many times already, believe it or not. Well, not many times, but enough. What trig identity should I use for this one?
Half angle.
Yeah, because 15 is exactly half of an angle that I know, so it makes sense. So you want to look up what cosine of half of an angle is.
Plus or minus the square root of 1 plus cosine 30 divided
Yes,
by
good,
2.
good. So if 15 is this, then this is 30. And tell me, which one of these will it be, since I know what quadrant I'm in?
Positive.
Yeah, it's going to be positive. So this will be the square root of 1 plus cosine of 30. Is everybody cool with that? I mean, if this is theta over 2, then theta must be 30. And that's why we use this one, because it helps me double the angle, and then it becomes an angle I know shit about. What's the cosine of 30?
Square root of 3 over 2.
Good. Square root of 3 over 2. Now, this is really messy, not just because I can't write, but because we don't like fractions inside of fractions. So I'm going to double the top, and I'm going to double the bottom, make it 4. Square root of 4 is, Jeff, come on. Square root of 4 is 2. Jeff. Now, did somebody else have a different way to do this problem? Did somebody else think of another way to do this problem? Isn't this cosine of 45 degrees minus 30 degrees, for example? Yeah, and your answer will actually be, let me see if I can guess what it's going to be. Square root of 2 plus square root of 6 over 2, maybe? I don't know. You'd have to do it all. I don't know what that was. And this is where I'm really pissed off at myself, because I used to know how to, let's see if this makes sense. Denest. Don't I have a nested radical? Isn't there a radical inside of a radical? It's all nested in there, like nested dolls, the Russian nested dolls. So to denest means to rewrite this so there's no radicals inside of another radical. And to be honest, I haven't really sat down to try to remember. I tried to remember the other day during class, and I just haven't sat down to try to remember. I'm like, I used to be able to do that. Anyway, let me erase this. Hopefully this one, does this look like something? Let me write it like this: cosine squared of an angle minus sine squared of an angle. Isn't that equal to something through, that's not cosine squared plus sine squared, right? That's too bad. If it was a plus, it'd be quick. But what's cosine squared minus sine squared?
Cosine 2 theta.
And why is that kick-ass? Because what's twice the angle we're talking about here?
Pi over 4.
Yes. And pi over 4, that's easy. What's cosine of pi over 4?
Rad 2 over 2.
Rad 2 over 2. All right. All right. I really hate calling on students, and I'm not going to start. So I'm going to assume everybody out there knows the answer and just like, I know the answer. It's too easy, Jeff. No, is that not true? Now, what the shit can we do with this? You cannot make a triangle based on this and then figure out the sine, because this is in the way. I'm not talking about this angle. I'm talking about twice this angle. So this guy's triangle will not help. But I do know how to handle sine of twice an angle, don't I? What's sine of twice an angle?
2 sine that angle, cosine that angle.
I can rewrite this as 2 sine of the angle, cosine of the angle. All right, I've spent too much time on this thing, so I'm just going to kind of blast through this. If I draw, let me do this in a different color. All right, if I draw my triangle, tangent is 3/7, so this is going to be 3/7. This is the angle I'm talking about. So this would be the square root of 58. Is that right? Sure, we'll say that's right. So then this will be 2 times sine would be 3 over square root of 58. Now look what I'm going to do. I'm not going to rationalize that. I'll show you why in a minute. Because here comes cosine. What's cosine going to be? It's going to be 7 over this, right? And do you see how these are going to rationalize themselves for me? So I get twice 3 times 7, that's 42, divided by 58, and I can reduce that to 21/29. Does that look right? I don't know. How do I check that? I throw this shit in my calculator, and then I throw this shit in my calculator, and I see if the decimals are the same. You can always check that. Okay, that's enough. That's enough of that. We need to do some, oh yeah, it's already 6:07. We desperately need to do some more law of sines stuff. Let me turn off the moon. That's no moon. No, it is the moon. Okay. Work with me. There we go. Not this guy. Oh, no. All right. That's for emergencies. All right. Let's see. Get out of here. So let's say I have a triangle. Let's
We
do a
are
nice-
not pointed at you.
Oh yeah, okay, that would help. Give it. So let's say I have a triangle. Let's see, what do we got, Jeff? Let's say this is 22 degrees, and this is 6. And let's say, sure. Yeah, okay. Let's say this is 40 degrees. So then what's this?
$118.
Yeah, so this is 62, so that'll be 118. So this is the first piece of work we did, right? So this would be what's given to me. A side, so angle, angle, side. I'm not going to make a huge deal out of these. Does this sound familiar to anybody from geometry? Angle, angle, side, angle, side, angle, side, side, angle. Side, angle, side, 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 side. Anyway, sorry. Because I could teach this in terms of memorize which situations sines works for, memorize which situations cosines work, law of cosines works for. It's so much easier to just say, does anyone remember? I told you how to tell when to use law of sines. Can I use law of sines on this problem? What tells me that I can't? What? All right, let's start with this. What the hell is law of sines? What is the law of sines?
Is it sine of 40?
No, just in general. Stop. Sine of A over
A.
little a. Yeah, sine of angle A divided by side A is the same ratio as sine of B over side B. It's the same ratio as sine of angle C divided by side C. This works for every triangle in existence. Let me be careful and say in Euclidean geometry, which is the one that we use in this class. Are there other geometries? All right, kids, where you can have a triangle with more or less than 180 degrees. Yeah, buddy, they exist. That's all I'll say. Sorry. All right. Now, does it make sense that the only time law of sines can be used is if I can have a complete ratio, if I have enough information to fill in a full ratio? If I cannot do that anywhere, I can't use law of sines. I need to be able to fill in a complete ratio, and then I can use anything else, and I can solve for the one letter. So, for example, here's a problem I could not use law of sines on. If I told you this was 38 degrees, and this was 11, and this was 15, right? Can you see why I cannot use law of sines on this? Can I make a complete B ratio? No. What about a C? No. What about an 8? No. I can't make any complete ratio. So I'm always going to have two unknowns whenever I try to set these up. Does that make any sense? Okay. I don't know. If you prefer, this is side angle side. So the sassy ones have to use law of cosines, which we haven't even talked about yet. Everything that law of sines cannot handle, law of cosines can, and vice versa. They kind of fill each other in. It's really nice. Law of sines says, I ain't got this shit, and law of cosines, I got you. Right? So it's such a nice relationship. Okay. Now, coming back to this. What's the ratio I can set up completely?
Sine of 22 over 6.
It's 1 at 22 degrees divided by 6. I like it. And then it's up to you. I got two things to do. It doesn't matter which order we do them in. What's another ratio I can set up to figure out what A is? Somebody else. What ratio can I set up for A?
Sine 40 degrees over A.
Yes. Sine of the angle divided by the across side. And I can solve this for A. Right? Let's see if you guys can do this. So A will be 6 times sine of 40 divided by sine 22. You just throw all that shit in your calculator. Make sure you're in listen to me. You're in degrees. Learn from Jeff. That horrible test where I got everything wrong because I was in the wrong mode. All right. Has anybody got that? Anybody got that?
6.15.
Sorry?
6.15.
No. I wonder. Oh, shit. Well, if you're in radians, you would get negative 505. So if you're sitting out there going, I don't know how I got negative 505, you're in radians. I'm not sure how you got.
Oh, I wrote it down. I'm sorry.
Okay.
10.30.
Yeah, it's like 10.295, so 10.3 sounds fine to me. So now we know side.
10.3 sounds fine to me.
There it is. I'm a poet and didn't realize it. Oh shit. Sorry, it's an old joke. Are you guys? You gotta love this shit, right? Isn't this so much? You got it. You just gotta love this. Isn't this better than some of the other stuff? Now I love all this shit. But if I were a student in this class, this would be a breath of fresh air. This is kind of much more regimented. It's much more recipe-ish. It's much more throw shit in and do it. It's not like try something, it's okay. I have no idea. And so the other one to figure out what B, sorry?
Being weird anyway.
Sorry,
Sorry, you quit it. I said the fun of cooking is just messing around with it anyway, though, right?
Oh, I'm sorry. I don't mean to put math in your food. That's horrible. It's going to taste terrible. What's the other ratio I can set up now to figure out B?
118 over B.
118 over B like that?
Yeah.
No. What's missing?
Oh, sine.
Okay. Otherwise, the whole thing goes crazy.
Huh.
All right. And now, in a similar way, this will become b. Let me see if you guys can follow. So I bring this up, I bring this down, and I bring this up. So it'll be 6 sine of 118 divided by sine of 22. So it's almost the same thing here. I just got to replace 40 with 118, which is actually how I do it in the calculator to save time. Bam. Who's got that? I kind of like this. This is the
14.14.
14. I like it. Now, see, does it make sense? Which angle has the biggest mouth?
The 118-degree one.
Yeah, and its side is the biggest side. It makes sense. It opens up the most. So, of course, the side across from it is going to be the biggest. The middle side, it's 10.3, is the middle angle opens up to be the middle length side. And then the smallest angle, little tiny mouth, has the smallest side. That's so awesome. That makes so much sense. Okay. Now, that is a nice one. Do you guys remember yesterday where I had to pull out the stops and I had to make a triangle and do this and I was swinging it around? Remember that? Remember that? No, some of you guys weren't here, so don't look at me like that. But it was neat. I loved it. Maybe I'll do that again. Why is this not the one? What is the situation? Somebody remember? It's very easy to remember what situation you have to be careful about where there might be two answers.
S.
Yes, ASS. Most other professors will say SSA, and I'm like, why? Just own it. Which one is going to be the ass? The ass is going to be the ass. That's so easy. So it could actually have 0 answers, 1 answer, or 2 answers. Hopefully that makes sense, right? There's 3 possibilities. 0 answers, 1 answer, or 2 answers. Okay. All right. So let's try one out. Let's see. Oh, yeah, I'll have to do that one. That's a law of cosines. I can't do that yet. Let me see if I can do this real quick. All right. So one way this could happen is if I give you an angle. Oh, let me make this. So I give you this side. Let's say the side is 15. And then I give you this side. Let's say this side is what makes sense here, Jeff? 10. Now let's hope. Yeah, see, I'm making one up. This could have no solutions. This is exciting. And I give you this angle. Let's say this angle is 39 degrees. Okay. Is that the same angle I used yesterday? I think so. Who gives a shit? All right. I really want this understood. So I've got the pieces parts. I know this angle is 15. I know the angle between, this side is 15. The angle between it and the side here is 39. I have no idea how long this one is. I didn't tell you that. And I gave you this side is 10. So here's the idea. This side has got to connect to this side. You guys with me out there? So one answer is, there's one possible answer right there, and this length would be this then. This would be 10. This looks like it's going to be the longest side. Does that make sense? That's one possible answer. Is there another answer that makes sense? Holy shit, there is. This triangle. I like it. By the way, I came up with this about 5 minutes before yesterday's class, and I was so excited because it works beautifully. All right. And it's so freaking low tech. It's awesome. Okay. So some of you guys are out there going, what does this shit mean? So I gave you a side, and an angle. Angle, side, oh no. So I didn't tell you how long this side is, which is why this side is allowed to kind of like rock back and forth. Does that make sense visually? Why there might be two answers here? Okay, so let's see what happens. Let's give these guys some names. Let's call this one A, so this is angle A. Let's call this one B, so this is side B. We'll call this angle C, so this is side C. Okay. So what is the complete ratio that I can set up?
Sine of 39
Good.
over 10.
I'll make that so big. Now, what is the only other thing I can find right now? Because which do I know nothing about? The C's. I don't know shit about the C's, correct? So I can't do anything with them yet. I have to do the B ratio first, don't I? So this will be sine of, I don't know, become a better B. All right, divided by 15. Now here is the, I wish I wouldn't have erased that first problem. The first problem, we knew all the angles, didn't we? Did we have to use inverse sine anywhere on that first problem? No. That is another reason why it makes sense that there might be more than one angle answer. Because inverse sine, what's the range of inverse sine? Is negative pi over 2 to pi over 2. It doesn't go up to 180 degrees, correct? And an angle in a triangle could be between 90 and 180. It could be bigger than 90, couldn't it? Inverse sine could never tell me that. So the answer to an inverse sine could be a reference angle for an angle in the second quadrant. This is aggressive Tai Chi. All right. And this is my hopeful Tai Chi. Please get it. All right. So if I go to solve this, is everybody cool? I'm going to multiply the 15 up, and then I'm going to apply an inverse sine. So I'm going to B equals the inverse sine of 15 times sine 39 divided by 10. Is everybody cool with that? Bring the 15 up, apply the inverse sine to both sides. Right, because if I do the inverse sine, it's going to kill, it's going to kill this. Inverse sine, 15, and then there, okay. So if you throw all this in your calculator, you're going to get an answer. I'll call it B1. I really need to manage my space better. You guys keep going. Let me rewrite this a little bit so I have better space. All right, we could do this shit. All right, so anybody manage to get an answer for that? I don't know. Go ahead.
E equals approximately 70.731.
70 points. All right, so we'll say 70.73. So that's B1. So what I'm going to do, the way that I like to do, well, this could actually come out to no solution. It could be your calculator can go error or whatever, and that means there's no triangle, right? All I have to do, let me see if I could do this. Here's a visual of something that has no solution. Oh, do I want to do that to you? Will you survive? I don't know. What if this was here? Here we go, Jeff. There you go, buddy. What if this side was this long? Is there any answer? Does it ever reach the other side to make a complete triangle? No. So if I made that number too small, there would have been no solution. You guys kind of with me out there? So it's sort of like somebody giving me parts to make a triangle, and then I'm like, the parts you gave me ain't gonna do shit, man. There's no way to make this triangle. Oh, I'm sorry, I meant this thing. Oh, okay, that works. All right. No idea why they talk like this, but they just do. All right. So look over here, what I'm gonna do is, what else could be B? What's the other option for what B could be? If it's 70.73 here, what would it be in the second quadrant? What would this angle be? If this is the reference angle. You can do it.
Uh, 109.27.
Yes. So it could be 109.27 degrees. Now watch. There could be one answer. This could be the only answer. How do I check? Does that work with this and leave something over for this? If A is 39 degrees, is there a possible, is C2 have something, is there something left over for C?
Yes.
Yes. How much exactly? Is it 31.73? So real quick, if I would have gotten something here and this would have been 150, right? Stay with me. If I would have gotten something here, let's say I got 30 here. So then this would have been 150. Is that possible if that's 39 and 150? Is that possible? Why is that not possible? If I would have got
It's
one,
180.
because it's more than 180. There's nothing left over for another C to exist. That would be a situation where there's one solution. Oh, look at that. That's almost perfect. I think that's perfect. Yeah. So there's the one solution would be like this, where there's one answer, but if I move it, there's nowhere else it hits that line, just that one place. So that would be where one answer, but apparently we're actually in this situation. There's one answer like this with a big ass C, and then there's another answer with a small ass C. No idea if you guys are with me. Erg. So now I just finish this out. What would C1 be? If B is 70.73, what's C gotta be? What's left over for C? All the angles. Sorry?
70.269.
70.27, we'll say. That's a neat. I like that. 140, 40, yeah. I wish I could say I tried to make that happen, but I didn't. Now, real quick, have I solved the triangle?
Not
I
yet.
know side A, side B. I know angle B. I know angle C. Do I know everything?
Need side C.
Ah, shit. Yeah, I need side C. All right, so that's the last thing we do. To finish this out, we got to figure out what side C is. But now I know that angle C is 70.27. So now I can use this ratio, sine 39 divided by 10 equals, now I can do the one for C, sine 70.27 divided by C. And now I can figure out what C is. Maybe I should do it. Let's see. Well, this is really awesome. I like this. Sorry. Anybody get that yet?
Fourteen.
Yeah.
496.
Yeah, 14.96. Why does that make sense? Who's got the biggest mouth in this thing?
B.
B, just by a little bit. So side B is just a little bit bigger than side C. That makes sense. That makes so much sense. Now, this triangle.
I didn't
Oh,
get.
yes.
I didn't get 14, and I don't know why.
So what'd you put in the calculator? You should have put in there sine 70.27 divided by sine 39 and times 10. That's what
Wait, I put that in.
Huh? Oh, you did? Okay.
Yeah,
What'd you get?
15.14. See?
No, you didn't do that. I don't know what you did.
I am showing it on the camera. Does it look right?
Wait. 72. Oh, you made it 72.27. It's 70.27.
Oh, why did I write 72?
I don't know. All right. Now,
You're talking about hyperboles.
so this is one solution to the triangle. We got to figure out the other solution to the triangle. So angle B could have been this, which leads to this. Or it could have been this, which leads, so I still, let me see if I can, so here it is. Let me see if I can draw this triangle for us over here. So it could look like this instead. Where this is 15, this is 39, still. This is 109.27, and this is 31.73. So now side C should end up being crazy tiny, right? This is still side A, which is 10. So that is this, right? I just drew this triangle there. Is that cool? So now I just got to figure out what side C is. So I can do sine 39 degrees to 10 equals become a thing. Sine of 31.73 degrees to C. And now when you do that, it should come out very tiny because it's got a little tiny mouth. So it should have a little tiny stick. Little tiny stick. For the little tiny mouth. There we go, that looks good. So just to cut to the chase, I get 8.36. So those are the two triangles. This one is this triangle. This one is that triangle. So there's two triangles we could build with the parts we were given. All right. Here. Last thing we're gonna do real quick. I'm gonna very quickly prove law of cosines just to get it out of the way. So then tomorrow we can just focus on examples of law of cosines. Here we go. So let's see. I have spoiled you guys. Some of you guys thought I was going to let you go. Too bad. Has everybody got everything up here that you want? Okay, here we go. Erase the ass. All right. So I'm going to draw a picture that's going to look kind of similar. I keep using the same triangle, but it's just a very good triangle to use. All right, now let me remind myself, I kind of did this ahead of time just so I can remember all the stuff. So this whole thing is B. I'm going to call this little piece X, and I'm going to call this little piece Y. Okay. Woo, baby. Can somebody tell me, oh, so that means that this is angle C, this here is angle B, this here is angle A. Is that cool? Across from their lowercase sides. Can somebody tell me what X is from this triangle? Of course, these are right triangles here. What's X in terms of sides and angle? In fact, use A specifically. What trig function you want to use for this angle that would give me the ratio of those?
Cosine.
Yes, so cosine C. Now let's see if you guys, can you guys start looking at it like cosine C times A gives me the X piece. Cosine C means the fractional amount in the X direction of this guy. In fact, can you guys, let me start to throw this in your brains. If I shine a light straight down, isn't this the shadow that my hypotenuse would cast? Yes, some of you guys might have heard this before. It's a very standard trig kind of thing to do. So that is the cosine is the fractional part of A that lies, let me write it like this, that lies in the X direction. So I multiply the hypotenuse times cosine, and it gives me the X piece. If I multiply, I'll get the, do I want that? I don't think so. Yeah, sure, why not? What's H then? Doing a very similar thing. What's going to give me this piece? What am I going to multiply A by to get the Y piece?
Sine C.
Yeah, sine gives me the Y piece. Let me make these uppercase C's. My angles are uppercase. Okay. Now, real quick, what is Y in terms of B? Well, let's see. Let's start it off easy. What's Y in terms of B and X? Let me put this over here. How do X, B, and Y relate?
Y equal B minus X.
Good. So then that means Y equals B minus A cosine C, yes? Yes, because that's what X is. Is everybody with me? So obviously Y is B minus X, and X we figured out is this. Nothing crazy yet. Nothing that crazy yet. Okay. Now, Pythagorean theorem with this stuff, right? Wouldn't C squared equal H squared plus Y squared? Nothing crazy there, right? Yes? No, I'm crazy. Is that right? C squared equals H squared plus Y squared, yes? Okay.
Yeah, of course.
All right, I like it. All right. We know what H squared is. We know what H is, don't we? We know H is A sine C. So this will be A squared sine squared C. Is that all right? Let me make this uppercase. Dadgummit, Jeff. Right, H squared. H is A sine C. So H squared is A squared sine squared C. Not a big deal. Y is going to be a little bit grosser. Too bad. Y is B minus A cosine C. All right, so just cutting to the chase here. This is so kick-ass. This is so kick-ass. All right. You keep using that word. I do not think it means what you think it means. I'm going to FOIL this out real quick, right? So this will be plus B squared minus 2A cosine C. I'm sorry, 2AB cosine C, right? If I FOIL this out, you guys can check me if you don't trust me. Plus a squared cosine squared C. Now look at this. What is this plus this? Let me put it up here. What's a squared sine squared C plus a squared cosine squared C? You can do it. What comes out of both?
2a squared.
A squared, and what's left inside is sine squared C plus cosine squared C. And what's sine squared C plus cosine squared C? Freaking 1. So this shit becomes a squared. That's it. Plus b squared. Does that look familiar so far? A squared plus b squared. Does that look familiar so far? It's the freaking Pythagorean theorem. And then, but then I got this little adjustment. Now watch, real quick, watch. Last thing. If C was 90 degrees, so if it was a right triangle, if C is 90, what is cosine of 90? What is cosine of 90 degrees? 0. This goes away, normal Pythagorean theorem. This is the adjustment term if C is not 90. Please let that kick just a little tiny ass somewhere. It kicks a little tiny piece of ass somewhere. All right. It kicks the smallest ass. Okay, that's fine. All right, that's enough, guys. So tomorrow, this, and to be honest, we'll go over, it doesn't matter where C, A, and B are. So we'll talk about that a little bit, but we'll do some examples of law of cosines. Okay. That's it. That's enough for today. So let me know if you need to hang out. If you are in another room watching TV, you can come log out now. If you need to hang out afterwards, let me know.
Later.
Okay, see you.
Sure.
Good. All right. I'm going to head out. See you guys.
Professor,
Oh, yes.
Have a good night, Professor.
See you.
really quick before you go, I wanted to know if we could go through the quiz 8, just some of the questions I had.
Sure.